So save your applause for later, please. Good, it's a full house, it seems. Let's get started. So before we begin, hands up, who knows what Beekeeper is? Great. So later on, you can check out our booths and ask us questions around Beekeeper. I will just give you a brief introduction to give you a bit of context of why what we've done kind of makes sense for us and what you can take out for yourself that you can later on do for yourself. OK, let's get started. Beekeeper has a long history, actually. We are a startup, scale-up now. When I joined Beekeeper in 2015, we were 10 employees. Today, we are 150 employees. However, the journey of Beekeeper has begun even before that. So Beekeeper was actually founded in 2011, so 8 years ago. And it was a side project. It was just something that our founders did on their own when they had time. After that, they actually rebranded, made a small pivot into more of a social online community thing for students. Turns out that students don't have that much money, so it's hard to make money off students. So we switched to something else. We switched to selling to companies. And that was in 2013. Why is that important? That is important because the technology we kept taking with us while we were doing these switches. So when the code base was started, it was mostly Python. I'm not sure if Python is all that relevant to you, but it was all Python 2.7 and all in one big chunk. So the complete opposite of what we have today. We were 3 engineers, I joined in 2015. We were still 3 engineers in 2015. And we are just trying to make things work, just trying to, to optimize for time for market, than actually doing things right. That was more important back then. And then you fast forward until today, in 2019, we've changed. We've changed a lot because we've had now customers. We had more and more customers, and that meant we can't just wing it anymore. We can't just do things, whatever works, works. We need to make things work. And we can't just keep breaking things. So we decided to split things into smaller microservices. And as of today, we have something around 40 microservices running. And while going through that journey, we had to figure out step by step on what do we do to make sure that all of these small bits and pieces that we do are maintainable, easily changeable, and all the other jazz that you usually get from, from technology that supports you. Just as a small side note, at Beekeeper, we do like hexagons, so you will be seeing today a lot of hexagons. So hands up, who knows what a microservice is? Perfect, everyone. This slide is useless. But then still, to be all on the same, to be aligned, really what we understand at Beekeeper for microservices, it's a process running on its own, isolated, having a single responsibility. And it is not to be confused with things like a DB layer or a UI layer. Usually, most of our microservices have a bit of everything within them. They're fully self-enclosed, and we create the services based more on domains, on things that we want to do, instead of what they are. So here is a very, very simple example that I came up with within a chat application. We usually have an API gateway that goes to a chat service that relies on a user service to figure out who you can message. Maybe sometimes you even have some asynchronicity to make this structure even more modular with an event pass. So that is a very simple diagram. At Beekeeper, we usually don't say microservice anymore. We say service, mostly because we don't want the size of the service to be the determinant factor of what goes into and what goes out. So we wouldn't do user service 1, user service 2. Now that's, if it still talks about users, it goes into the user service. So the question when we were 4 years ago, why go into microservices? Why not just refactor the monolith completely and you know, call it a day and still have this one big of monolithic structure? We went to monoliths. We went from the monolith to microservice architecture because of several reasons. They might not be the same for you as they were for us. Back then, changes to our software was really, really hard because we had to deploy all the code at the same time. So if we wanted to make changes to users, we also had to deploy all the other changes we made to chats, to search, to everything else. We couldn't deploy them separately. What that also meant is that because it was so coupled and that changes could break easily because we didn't see some dependency. We had a lot of regressions, so we had to roll back, and then all of the new features were gone. That was usually sad. Finally, because of all these constraints that we had, we made it better and at the same time worse by adding a more thorough release cycle. So then we had a staging area with all this stuff, and then a production area and a development area. So when we made a change to a particular part of the monolith, we had to wait 2 weeks until it actually hit production. We wanted it to be faster. So pretty much the same stuff on this slide. We wanted to have a much better release process. Actually, with microservices, we decided to have a continuous deployment cycle. So whenever you merge into master, that's deployed. You have to be sure things work. Most people probably of you know how to do that. But more interestingly, we also wanted to open the door for new technologies. Whether it's Java, Python, or JavaScript, whatever technology you pick, it will not always be the best choice. So a single technology will not always be the best choice for your problem at hand. For us, for example, we do have a significant part where web is important. And server-side rendering is much, much easier with Node and JavaScript than it is with Java or Python. So with a microservice architecture, we can leverage that. And we wanted to leverage that to see, OK, maybe we want to try out Go, see how it goes. We wanted to have better availability and scalability. We wanted to be able to scale these parts independently of each other. Just because the search service is being hit every time doesn't mean that I also need to carry the weight for users or some other parts of the system that are being accessed very infrequently. A very nice part of microservices is also the case that if you have failures, you will have you in most of the cases will have failures that are self-contained or contained within smaller bits of the system, and not the entire thing goes down. And then that's usually worse than just saying, OK, you cannot search in the system versus the system doesn't work. So that's where we started out. Just as a side note, all of these things that I talked about today, they are not new things. They're not incredible things. They're not things that you haven't done before. The things I talk about is these things, but at a different scale. Previously, within the monolith, if we had to do a logging integration, we did it once and it was done. Here we have to do it now 40 times. If it was about database access, we had to do it once, not 50 times. So these things they talk about today, they're becoming much more impactful on this scale than when you just have one of it. At Beekeeper, we have a very strong DevOps culture. What that means, our developers, when they write code, they don't just write code. They actually provide solutions to our customers. So what that means is that they are responsible for deploying the software into production. It's even more so important with a microservice architecture where we want to deploy multiple new services sometimes within a week and not want to hand this over. What that means is at the end, we have a couple of parts that we have identified that are important to us, like, well, having a good developer experience that usually goes within developers, but also having metrics, having errors and alerting, having logs, all that stuff becomes very important to our developers as well. With that, let's actually go into what we did. So this was all introduction, and now let's actually go what we did. When we started out, we said, for it to be successful, it needs to be as easy to create a new microservice than updating the monolith. Otherwise, we will tend to go and update the monolith. We tried our best to make this true, but it was a journey for us. So we started the developer experience from this triangle, and the first thing that we needed to decide on, a framework for us to use. We decided on Drop Wizard. Is it the best framework? I don't know. It is a good framework for us. It allows us to reuse a lot of the stuff. It allows us to bootstrap. It's good technology for us at the very end. However, the bigger challenge that we actually faced after making the first decision was, do we want to go single or multi-repository? There is a lot of opinions around that. I don't want to go into that today. We chose multi-repository, which came with actually a lot of the pains that we had to solve later on. That might not necessarily be there with a single repository for all your services. Maybe a quick show of hands for all you who develop with microservices, who have a single repository for all the code. And who has single repositories per service? Beautiful. This is what we have, and this is where a lot of our challenges lie at the end of the day. So the first part, which is a kind of obvious part that we ran into, is, we want all of our setups or projects to look similar. So with every new microservice you need to create, in Java you need to create something like a GRADLE wrapper, build.gradle, then your multi-projects. If you're using multi-projects, we like to use multi-projects. So all this setup you have to do. And within the monolith you get that for free because somebody has already done all the groundwork for us in a new microservice world. We did it once, and then we started copy-pasting it and copy-pasting it. And for everyone who's a developer in here, you know what happens when you start copy-pasting things. You usually forget something, and then suddenly your user service is called a search service because you've forgotten to update this one file where it says search service instead of user service. Luckily, we didn't have to look far for a solution. We started using Yeoman. This is the thing that I would now recommend everyone, that you use a generator for that. Whether it's Yeoman or something else, pick your poison, but use something. This is really, really key for us to go from 30 minutes to an hour of bootstrapping into simply 3 minutes and you're done. You don't have to think about on how do I set this up now to make it consistent within the project. And it's especially true for a growing company where year over year you have twice as much developers. So it's likely that the new service is being created by somebody who hasn't done it before. And then it becomes even more interesting because once we fixed that challenge, it was easy to create a lot of services. We had the next challenge, which was that we develop with Java, as you probably can guess by now. We make use of GRADLE, and we want to have some cool things because of that. And the Java ecosystem is actually very strong with these parts, like automatic code coverage analysis with Jacoco, or you want to do static code analysis with Spotbox. Granted, with Java 11, it's kind of spotty, as the name implies, but it still works. We want to have automatic code formatting and verification that your stuff is actually correct when it comes to our coding guidelines. We want to check our dependencies for known vulnerabilities, and we also want to check that the dependencies we're pulling in, are kind of okay, that we, suddenly don't have a big legal issue on our hands. That's easy, right? That's easy to do. It just requires a lot of Gradle configuration that you can't even read because it's so much. You need to pull in all the Gradle plugins. You need to configure it to match your stuff, which is cool, which is really cool because you can do that, right? But that also meant for us that now we had 20 to 30 of these in different repositories, and whenever we found, oh, that's actually cool to add, guess what? 13 new pull requests. And manual labor involved, right? So it's not really that maintainable to have these super configurations doing it yourself. However, what we actually found out that, and what we did, is to just create our own Gradle project, Gradle plugin. And all what you had before, all of this on the left side, becomes one line of Gradle configuration in the beginning. That pulls in everything, it configures everything, and it even comes with a command saying, hey, just check if you're at the latest version. And that's what you have to do, and when you want to then update this or maintain this, you just need to change the version number. This is something that I would have wished we did in the beginning, not at the end, because it does save so much time. Actually doing it is so much easier than you would think when you think about, build projects. Nobody likes to think about build stuff. Everybody feels it's very, very complex. It's actually super easy because of the nature of Gradle, where the configuration you write is actually code. It just looks nice. So you can very easily do it with Java in a plugin and pull it in. Actually, the longest, the thing that took us the most time was to get our plugin on the official Gradle plugin store, or whatever they call it, because they have a manual review process, and it took them a week for us to actually get it there. Other than that, it's really super simple. It is exactly, is this readable? Yes, more or less. It's actually pretty much the same what you would put into your build.gradle file. Cool. So we go to testing and test coverage. Who of you, quick show of hands, who of you likes tests? Who of you doesn't like tests and feels it's stupid to write tests? No? At least no. But you don't like, some of you don't like writing tests, apparently, which is okay. For us, tests with microservices are super important. Why? Because, well, what is this? No, okay. I will come to later why. What we realized also with microservices actually is that testing becomes much, much harder. Now, instead of having all the code within one single block, which you can just, you can make crappy integration tests and you have all the code that will kind of run, you cannot, because your chat service might require bots and user service. And then if you want to bootstrap that and start that, you now need to understand how these work to make sure to start them. And then if you want to write a single test to test the entire chain, it becomes a lot of effort, and nobody wants that, right? However, it is also really, really important to have these tests, as we will see in a second. So what do we do? You might already have seen some of it. Since every microservice for us is a multi-stage or what is it called? Multi-project project. Each of these services needs to also publish a test support module where you have all the mocks. That is a contract for you already. What that means is that when you actually run the tests, you don't test against the running service, you run against a version that has everything mocked. We use wiremock for that. And that tests even itself later on, or in its own package, that what you're actually returning makes sense. So you can actually do tests that make it easy to start, are fast, and are a very good abstraction of what you actually want to test. It usually looks like this, a bit like this. So you can create your own rule, user service test support. Drop Wizard comes also with some test support classes, and then it becomes really, really easy to take a user that already exists. You can have configurations for users that don't exist, to check for error messages when you would like, in this case, to send a message to a non-existing user. This is also something that I would really, really, really advise you to do. Otherwise, you start not having tests. You start doing only unit tests, and maybe that's not enough. Why is it not enough? When you have this microservice, you will notice from time to time that you have to do dependency upgrades. You need to upgrade from let's say, from a Jackson version with vulnerabilities to a Jackson version without vulnerabilities. That is a change that might be breaking you, that might break your entire application. But you don't want to go and test every single microservice to see if that works. So these tests are actually core for you to not just write new code, but also to just maintain the entire life cycle of tests, of the service. Finally, we go into something that is more DevOpsy, that from tests, we have now verified that our software runs, but that's not enough. Because, just because we've tested something doesn't mean it will actually run in production well. There's still things that can happen on the way, like misconfiguring something. Like, I don't know, how many of you use AWS for your stuff? Not many. If you were using AWS, you would understand how hard it is to set up the permissions within AWS without making publicly accessible to the internet. It is actually pretty hard. So what happens is that you take this perfectly developed piece of software and then you put it into production and it doesn't work. And one of the things that we at Beekeeper want to do is we want to be the first ones to know when things don't work. So we add additional checks. We have defined for ourselves which checks we want. We have health checks, which just say, hey, can a service talk to all of its dependencies? Can my user service talk to the database? Yes or no? It's really, really simple checks, but you'd be surprised how often these checks have saved our butts, just because the database went down and then we knew exactly what was impacted. We knew that there was a network partition and we didn't have to debug. We immediately knew, oh, the service can't talk to a database. Or we deployed it into a new environment and it was like, oh, service can't talk to the database because we didn't create the users. So many things that can go wrong, even with perfect software. We also have other checks like sanity checks. If your service is long running and it does background tasks, etc., you just want to make sure from time to time that the data is in the state where you think it is, so that you can react and that you can be always the one to fix it before the customer complains. Finally, a bit of detail. We use Kubernetes everywhere in our infrastructure. It works better with a readiness check, so when we redeploy everything, it knows when it can actually start using it to serve data. Cool. Usually, a health check is extremely simple. This is what we have in our environment. For S3, for example, we are actually super lucky that Drop Wizard comes with health checks out of the box. Pretty nice, and it also delivers you actually its own health checks. You can reuse them for database connections. You get one for free, for example, with Dropwizard. Finally, logs, metrics, and alerting is one of the things that I also like to quickly talk about that we've seen with our microservices that is super important. Who of you today is using something like Kibana on Elk Stack for logging? Great. The rest of you probably just go on the terminal and try to figure out what is happening. Turns out it's actually much harder to do with microservices because now you have 20 different sources of logs and you don't want them to be in different places. So you do really want to have one single place for your logging. So you bring up an Elasticsearch, Logstash, and Kibana setup or something that is, like it. For us, again, this setup that we had, this is part of the configuration that we needed to do for every service. We had to do it in every service. And we had, again, exactly the same problem. Look, now we have 20 times the same pieces of code, whether it's in configuration statements, whether it is just setting things up. It was just everywhere. And whenever we wanted to change it, we needed to do 20 different changes, and then it started drifting, and it was just a bit of a pain to make use of all these things and change it. So, of course, we did the only thing that we knew. We created our own bundle. Dropwizard calls them bundles. These are the things that you do for reusing certain things, and all we have to do is just add this one line of code, and this makes it production ready in the Beekeeper way. This is what I would also recommend for you to do, that you just add one line of code, whatever that is. It has to be one line of code, something that you can easily update, and ideally it's just a dependency change, that for all your microservices it's the same. There is one little piece that I have not talked about. All of this just would not work with automation. I did not want to go today into too much of automation in general. We use Jenkins. It works for us. If you want to use something else, use it. But the very foundation of all of this really comes together with the automation infrastructure, that we do have pull request builds, that we do have periodic checks on our dependencies, that all is done automatically to reduce cost and save time. So that was a quick talk from my side. What is the conclusion? For us, the conclusion was that microservice and infrastructure or an architecture like microservices it's very cool because it does allow us to do these things that we wanted to do. But it also comes with a quite significant price, which is all the things that all the things that is set up, that is required for you to run a service. It doesn't provide real customer value. It's done so many times, like 20 times, 30 times. However, within the right tools in place, you can make it scale. You can make it scale easily. It scales wonderfully for bigger teams. And if you have teams where you have a DevOps culture, it really takes off well because people have the entire ownership of the entire thing. And this is pretty much it. Thank you very much.
Thank you. Thank you, Filip Wieladek. That's all. Now you have bigger break, and I don't know. Are there any questions, maybe?
What front technology you had on your monolith before the migration?
What front-end technology we had?
Yes.
Okay, so the question is what front-end technology we had before the migration. It was Python with Jinja templates. So it was just something that, at the end, we were doing with Python on our own, returning HTML.
Somebody else, maybe. Question?
Any other questions? Otherwise, thank you very much for your time.